Welcome, dear students. I once again welcome you to the chapter hydrogen. In the last video, I have discussed in my last video about dihydrogen and a little about water. In this video, I will be discussing about another important compound, another important product of dihydrogen or hydrogen gas, that is hydrogen peroxide. So let's see. Hydrogen peroxide, it was discovered by a French chemist J.L. Thenard in 1818. The chemical formula for this one is H2O2, and molecular weight, the molar mass is 34 gram for hydrogen peroxide. The next one is the preparation of hydrogen peroxide. Then hydrogen peroxide preparation means how hydrogen peroxide can be obtained in the laboratory. So basically two methods are there. First method is the action of dilute sulfuric acid, means when sulfuric acid mixed with water is treated with sodium, the product yield is hydrogen peroxide. And the next one is the action of same dilute sulfuric acid, which is cold, means cold sulfuric acid, the action on barium peroxide. So how from sodium peroxide, when it is prepared with sodium peroxide, the process is known as Marx process, where here the complete means this one is given, the setup is given how to prepare, means hydrogen peroxide is prepared by adding the calculated amount of sodium peroxide. What is basically said here means the amount of sodium peroxide required with an amount of sulfuric acid, that is calculated, and both of them they are reacted, and it is the reaction is carried out with, means slowly by stirring the solution. The reaction is carried out, and where hydrogen peroxide is present, where the reaction given is this one. This is sodium side, which is reacted with sulfuric acid, and here sulfuric acid is in cold condition, where this sodium sulfate, the product that yields, it comes as a precipitate. Now if you remember, precipitate means the insoluble substance which comes in a reaction which settles down, and hydrogen peroxide is obtained in this process, and this process is known as Marx process. The next process is the barium oxide process. In this process, paste of barium peroxide, which is again prepared with water, and the condition is that the water should be ice cold, means very cold water. It is treated with about 20% ice cold solution of sulfuric acid. Now 20% ice cold solution means here 20 milliliter of sulfuric acid is mixed with 80 milliliter of water, and that solution is very cold, a cold solution, where barium oxide is treated with that sulfuric acid, and the final product yielded, that is hydrogen peroxide along with some molecules of water. And here again this barium sulfate, it comes as a precipitate. Then this precipitate, it is removed by filtration, leaving out 5% solution of H2O2. Means the H2O2 that is obtained here, it is a mixture of, you can see here, it is a mixture of hydrogen peroxide and water. So these two are miscible. In this case, the product that is yielded, there only 5 milliliter of hydrogen peroxide is present, and remaining 95 milliliter is water. That is a ratio which I have expressed in terms of milliliter, 5 milliliter and 95 milliliter. Actually the solution is just 5% solution, means if the total solution is 50 milliliter, then there 2.5 ml will be peroxide, and remaining 47.5 ml will be water. Means the solution which is obtained, it contains only 5% of peroxide. Another one, the manufacture of hydrogen peroxide, these methods actually, these are not usually carried out because they are electrolytic reactions. These reactions are carried out with the help of electricity, where this is the setup how it happens, where 50% solution of sulfuric acid, means 50% solution means it's a dilute sulfuric acid, where 50-50 means half is water and half is sulfuric acid. That is, the reaction is carried out with a high density current, you can see here, and here the product yielded is this peroxo disulfuric acid, and this peroxo disulfuric acid, which is further hydrolyzed with water, means treated with water to give hydrogen peroxide. This is the peroxo disulfuric acid. This peroxo disulfuric acid, it is when treated with water again, we get this hydrogen peroxide. The next method of this one is, this is again a very costlier and lengthier process. So these processes are not normally used, but yet It is prepared from 2-ethyl anthraquinol. This is a chemical, 2-ethyl anthraquinol. Here two steps are there in this formation, where 2-ethyl anthraquinone is first dissolved in benzene, and through it hydrogen gas is passed, and in the presence of palladium, which is acting as a catalyst. Now after the first step, after the treatment of this ethyl anthraquinone with benzene and hydrogen gas, whatever the product is obtained, that product is again dissolved in a mixture of benzene and cyclohexanol, and when air is passed through it, we get the product as peroxide along with 2-ethyl anthraquinone we obtained here. The next one is concentration of H2O2. Now what is concentration of H2O2? The product in the previous cases, in all the previous cases here, we are obtaining hydrogen peroxide by different means. Now once when we get this hydrogen peroxide, next aim is how to store it, how to concentrate it. Then this again involves the following steps. The first step, the concentration can be done by the following step. The first step is evaporation on a water bath. Now what is a water bath? Water bath means in a vessel we will be keeping water, and in that water again in another vessel we are going to keep that solution which we have obtained from the reaction. You see here, the dilute solution of peroxide is transferred to an evaporating dish and warmed carefully on a water bath. In this process 30% of peroxide is obtained. 30% of hydrogen peroxide means 30 milliliter of peroxide, and the remaining 70 milliliter is water. In terms of percentage, it is 30% of peroxide. Next one is dehydration. Now dehydration means removal of water in a vacuum desiccator. Now desiccator is a equipment where by keeping in it we have to just vacuum out all the moisture present inside it, and in this way also the concentration of hydrogen peroxide is done, where here it is written that in this case 90% solution of hydrogen peroxide is obtained. 90% solution means it's very pure, extremely pure, where the quantity of hydrogen peroxide present is 90% in that solution. The next process is distillation. Distillation is a process where again this 90% solution is again distilled, where we get 99% pure hydrogen peroxide. Next one is the removal of last traces of water. Means that this 99% which we have obtained above, to remove water from that we have to cool it in a freezing mixture of solid carbon dioxide and ether, and then again what happens there, the crystals of hydrogen peroxide separates out, which are removed and then dried and remelted. Means this hydrogen peroxide, it gets condensed easily, and from there we obtain the pure hydrogen peroxide. Next one is storage of hydrogen peroxide. Once we have obtained this hydrogen peroxide, now where we are going to store it? This hydrogen peroxide is mainly stored in a waxed line colored bottle. Means it's made up of wax, because the rough glass surface causes decomposition. So wherever we will store it, then that storing vessel, it will be very smooth. The inside portion should be very smooth, and also a small amount of phosphoric acid like these all is generally added, which prevents the decomposition. Now decomposition means hydrogen peroxide, it decomposes very easily. Decomposes means it breaks down from hydrogen peroxide to its corresponding compounds. Now properties, what are the properties? The first property is that when peroxide is in pure condition, it is blue color and it is very thick like syrup, those cup syrups and all, it is like that one. Next one, it is more viscous, less volatile and dense than water. Viscous means it does not flow easily, less volatile means it does not evaporate easily, and it is denser than water, it is thicker than water. Next one, its density. Next one, its melting point and boiling point. It is completely miscible with water, means it is completely soluble in water, alcohol and ether in all proportion. It forms a hydrate with water in this way, means one molecule of water is there. Another properties that include are the chemical properties. Now what are the chemical properties? Mainly it behaves as a oxidizing agent. Also it behaves as a reducing agent in both acid and base or alkaline solution. The oxidation state of hydrogen peroxide, I will be telling you about the oxidation state, how to calculate the oxidation state. Here oxidation state of oxygen in this case is -1. So it is a very powerful oxidizing agent but a weak reducing agent. Means its oxidizing ability is more, means it can remove electrons from other, but also it can donate electron, but that one is a weaker characteristic. Oxidation action you can see in this reaction. In the presence of an acid, this can accept electrons. Oxidizing agent means it can accept electrons from other. So This is the reaction you can see. Here it is accepting electrons from other and it's acting as a oxidizing agent. Next one is reducing action. In these all cases you can see the reducing agent, reducing actions of hydrogen peroxide, and these all reactions you have to by heart by writing it again and again, and then you have to complete the following reaction according to the given condition in the question. Next one is oxidizing action in basic medium. This is a basic medium. These two are the basic medium, and this is the reducing action in basic medium, where iodine is when treated with hydrogen peroxide in the presence of any base, then we will be getting iodine again respective water molecule and then oxygen. These all are the reducing action of peroxide, hydrogen peroxide reducing agent. Now, what are the uses of hydrogen peroxide? Mainly, hydrogen peroxide is used for bleaching agent in the paper industry. Also, it is used as hair bleach and mild disinfectant. Disinfectant means it is used in mopping the floor of households and in hospitals and all. Next one, it is also used in the manufacture of many compounds such as sodium perborates, and these perborates are mainly used in the manufacture of detergents. It is used in that one. Mostly, hydrogen peroxide is used as antiseptic for washing wounds, teeth, and ear. Means whatever the ear drops or the eye drops which we have in our everyday life, it will contain some traces of hydrogen peroxide in it. And also, the first aid that is given to us to, in that case, if any wound is there, to wash that wound, we use hydrogen peroxide. Next one, it is used for producing epoxides in chemical reaction. This is used for the production of these compounds. Furthermore, it is used in anti-clor agent in bleaching. Next one, it is used in restoring the color of lead painting. Means when paintings, when it get this color, then again to restore the color we use hydrogen peroxide. It is used for the synthesis of these chemicals like pharmaceuticals. Means I already said that it is used in those ear drops, eye drops, food products like tartaric acid. Tartaric acid, which is sour in taste, it is used in that one. Next one, it is used in preserving milk and wine. Means by using hydrogen peroxide, not in more amount but in a lesser amount, it can be used to preserve milk and also wine. And recently this hydrogen peroxide, it is used as means in pollution control for this industrial effluents, oxidation of cyanides, and another aerobic condition to sewage waste. Means these sewage wastes that are thrown here and there, they due to aerobic condition they develop some foul smell. So this hydrogen peroxide in these days it is used in removing that one. Now the final thing that comes here is the structure of H2O2. Now in chemistry, whenever we are learning anything, we have to know the structure of that compound. And here the structure of the compound, it is in this way. When this H2O2, it is gas, you can see here, this is one H, this is one O, this is one O, and this is H. It is like a open book structure where the join of the two pages, there lies the two oxygen molecule, and one side it is the hydrogen and other side it is the hydrogen. Now here in the gas phase, this the bond between this H and this O, it is 0.95 angstrom, which increases in the solid phase to 0.9 angstrom. Similarly with the angle also. The angle here in the gas phase is 94.8 degree, and here it increases to 101.9 degree. Similarly here also, this angle, it is more in case of gas phase. The another angle, the below one, that is more in case of gas phase, and also this angle, it is less in case of solid phase, and here it is more in case of gas phase. So the strength of H2O2. Now what is strength of H2O2? In like strength, it will be expressed in two types. First one is weight percentage. Now what is weight percentage? Weight percentage means, suppose if I am saying that the weight percentage of hydrogen peroxide, it is suppose 22%, then in that case you need to understand that 22 gram of hydrogen peroxide is dissolved in 78 gram of water. Means the total weight of the solution is 100 gram, and there 22 gram of hydrogen peroxide is present. So that is one type where we express the strength in terms of weight percentage. The another one is volume. Here the strength of H2O2 is commonly expressed as volume. This commonly refers to the volume of oxygen which a solution of H2O2 will give. So now about this, the volume, how it is expressed, it is not used by us mainly, it is used by the pharmaceutical industry. But the another one, for your knowledge, I am just adding it here, that it is expressed in terms of volume, where we have to express it in terms of volume, that how much volume of oxygen will that solution of hydrogen peroxide will give, that is expressed in this term. So with this I end this video of hydrogen peroxide. So with this I end this video here. Thank you. Thank you for watching the video.